let's get started on the notes for stoichiometry. But before we do that, I'm going to give you one more quick example illustrating what stoichiometry is all about. So I'm going to give you a chemical equation. So we have 1/2 bar of chocolate plus 3 marshmallows plus 2 graham crackers will give us 1 s'more. All right, that's a chemical equation. It's endothermic because we have to apply energy into our reactant side. The type of question we are going to be asking is questions like, if I have 6 marshmallows, how many s'mores can I make? Well, that should be pretty obvious. 6 marshmallows, I would need 1 bar of chocolate, 4 graham crackers, then I can make 2 s'mores. So I can make 2 s'mores if I have 6 marshmallows. If I have 10 graham crackers, graham crackers, how many bars of chocolate will I need? Well, 10 graham crackers, that's 5 times this, so I would need 5 times this. I would need 2.5 chocolate bars. But then we're going to get into more complicated questions. Like, if I have a bag of marshmallows, how many s'mores can I make? Well, a bag of marshmallow, let's say, has 60 marshmallows in it. Well, that's 20 times this, so I can make 20 times 20 s'mores. Or I've got 300 grams of graham crackers. How many s'mores could I make? Well, that depends on how much each graham cracker weighs. But all of these calculations are all based on this chemical formula. It's endothermic. Right? So those are the types of questions we are going to be asking with stoichiometry. So let's get down into some of the examples. All right. So first things first. When we start with stoichiometry, I'm going to start with one of the harder examples. This is probably one of the hardest examples that you can do. Let's try to figure out some questions based on some logic. Okay, so first thing we have our chemical formula. Always first step, balanced chemical formula. That's step number 1. Write that down. Step number 1, balanced chemical formula. Always need that first. So let's balance this to get a balanced chemical formula. 1 Ag, 1 Hg, 1 O, 2 Os. Okay. So I need 2 of these guys, I need 2 of these guys, and I need 1. All right. Now we need to understand what these numbers mean. This means I have 2 moles of HGO will give us 2 moles of Hg plus 1 mole of O2. All right. So I can say if I have 4 moles of HGO, I'm going to get 2 moles of oxygen gas. If I have 4 moles of Hg, I will need 4 moles of HGO to make it. Now we can convert from mass to moles and then move on. So we're going to walk you through the steps for this question. Suppose we have 250 grams of HGO. Then the reaction takes place perfectly. So we get this exact ratio. We should be able to answer these questions. How many grams of Hg will be produced? And what is the volume of the oxygen gas produced? Right? We should be able to answer those questions. And we are going to answer those questions right now. I need some papers, which I hope I have. I'm going to need my formula sheets. Yeah, I got them here. Need your periodic table. Okay, so what we do is we start out and we identify what we know. We know 250 grams of HGO. 2 significant figures in that number. What are we trying to find out in the first question? In the first question, we're trying to find about our Hg. Okay, so we're going to set up a series of conversions. And then we're going to do that series of conversions. Okay, so the first thing I'm going to do is I'm going to write down, what do I know? Here's my steps. I know my mass of HGO, and that is 250 grams. From that, I can find my moles of HGO. Now that I've got my moles of HGO, I can use my chemical equation to convert from moles of HGO to moles of Hg, right? 2 moles of HGO will give me 2 moles of Hg, so I can use this to convert to, I can use this guy to convert to moles of Hg. Then once I know my moles of Hg, then I can convert to my mass of Hg. And that is the answer I'm trying to figure out. So we've got 1, 2, 3 conversions, and this is one of the harder questions. So to go from mass to moles, I'm going to use my molar mass. Then to go from my moles of Hg to my moles of HGO, I'm going to use my ratio 2 moles of Hg to 2 moles of Hg, 2 moles of HGO to 2 moles of Hg. That's from this chemical equation. Then I'm going to use my molar mass again at the end. Okay, now I read these out in my head and I write them out all the time. I've taught this course for a number of years and I always read them out and I always write out my conversions. So first thing, HGO, we need the molar mass of HGO. Hg, that's mercury oxide. So 200.59 plus 15.999 is equal to 216.598. So here's what I do. I write out my, how many moles are in 250 grams if 1 mole has 216.589 grams. Right? I say it out like that because that makes sense. And I always put my unknown, my next step, at the top. My previous step goes at the bottom. So I take 250 and divide it by that 216. And I get 1.154 moles. Now this should have 2 significant figures. Because our starting guy had 2 significant figures, so this one should have 2 significant figures. And I'm just going to track it along. Right? Because we should keep more than 2 significant figures as we're doing the question. Now we're going to do the second conversion. Ready? The second conversion. How many moles of Hg are there for every 1.154 moles of HGO if, according to our chemical equation, there are 2 moles of Hg for every 2 moles of HGO. Right? I've got Hg's all on the top, that's this guy. I've got HGO's all on the bottom, that's this guy. This 2 to 2 ratio comes from up here. 2 moles of Hg for every 2 moles of HGO. Basically, it's the same thing. And my answer when I take 1.154 times it by 2 and divide it by 2 is going to be 1.154 moles. And this guy would have 2 significant figures. So there's our second conversion done. Now we get on to our last conversion where we go from moles of Hg to mass of Hg. All right, so we use our molar mass here. And this is our third conversion. I'll do this guy in purple. And I write out how many grams of Hg are there in 1.154 moles if there are 200.589 0.59 grams in 1 mole. So we do 1.154 times 200 divided by 1. Oh boy. 200. Oh. 59 is equal to 231.53. 231.53 grams. Now, my final answer should be in two significant figures because I started up here with two significant figures, and all of this is multiplying and dividing. So I have to take my lowest number of significant figures from all of them, which was 2. So my final answer should be 230 grams of Hg. Did you follow those steps? Those are the steps that you're going to be doing. And I'm writing them out like that. Each step, map it out, write down my answer at each stage so it's easy to follow. Because these questions are pretty long, and it's important that I can go through and check each step and see where you went wrong. All right, so we're going to do the second question. What is the volume of the oxygen gas produced? Okay, so we're going to make a complete map again. So this time, in this question, I'm going to do this question in, I don't know what color. One of these colors, red. So now we're trying to figure out about the oxygen gas, but we still start with our HGO. So let's write out our map. What do we know at the start? We know our mass of HGO. And that's 250 grams. Then we're going to go to our moles of HGO using our molar mass. Then we're going to go from moles of HGO to moles of oxygen. And then then we're going to use our ratio from the chemical equation. Then we're going to go from our moles of oxygen to our volume of oxygen. That's using our 22.4 liters per mole. Okay, so what is our molar ratio? I call this the molar ratio. What is our molar ratio? Well, it's 2 HGO to 1 oxygen, right? So it's 2 HGO to 1 oxygen. I'm just writing it right there. That's my molar ratio. All right, so first question we don't need to do because we know that this is 1.154 moles. Now we do our second one, and I always put my bottom guy on the top. So I write down how many moles of O2 are in 1.154 moles of HGO. Not in 1.54. How many moles of O2 compares to 1.154 moles of HGO? If 1 mole of O2, right, that comes from up here, 1 mole of O2 to 2 of HGO. If 1 mole of O2 is in the chemical reaction for every 2 moles of HGO. So you do 1.154 times 1 divided by 2. Which is just 1.1541 divided by 2. My answer is 0.57712 moles. Right, so there we go. That's that conversion. And again, this should have two significant figures. These guys are just counts, theoretical counts of moles, so these have an infinite number of significant figures. And this guy should have 2 because this guy had 2. So this guy should have 2, so this guy should have 2. But we keep more in the question. Now we go to our volume of O2. So to do our volume of O2, I put this guy on the top. How many liters of O2 are in 0.57712 moles if there are 22.4 liters in 1 mole? right? So this number is still in my calculator, and I just times it by 22.4. 12.927 liters. And this should have two significant figures because we started with 2. We take 2 down, so it should be 13 liters of O2. There you go. We've just done the most complicated stoichiometry questions, almost. Limiting reagents are more complicated. But in the first section, these are the most complicated questions that you're going to get. All right, so thank you for watching. We will do more examples in this book. We'll just be doing examples, and hopefully you're picking this up as we go along. All right, thank you for watching.